I'm going to present you our work, Data Poisoning in Federated Learning, Clipping Malicious Updates. The problem we are dealing with is related to the federated learning scheme. In such a setup, while we are maintaining privacy, we are also introducing a critical vulnerability with respect to malicious or insecure nodes trying to poison the globally trained model. Our approach towards solving this problem is based on the idea of clipping the updates of the nodes that seem to be executing the data poisoning attack. We are testing three different techniques: fixed clipping, adaptive clipping, and dynamic clipping, and we compare the results on the MNIST dataset. Our key finding is that the dynamic clipping attack performs better than the rest in most attack scenarios. The fixed clipping approach is trying to penalize nodes that are sending larger updates by using a fixed threshold value. Adaptive clipping tries to adapt that fixed threshold using in fixed clipping by taking into account the beta quantile of the observed updates. Finally, dynamic clipping goes a step further and attempts to calculate a personalized threshold value for each one of the nodes according to how their updates deviate from the average updates through time. We have tested all three techniques on a federated learning simulation using the MNIST dataset. We used 100 nodes, out of which 30% are poisoned, and attempt to inject a backdoor triggering artifact at the lower right corner of the images. We tested all approaches for various configurations and compared the results with respect to accuracy of the global model. While fixed clipping was the best approach when poisoning only 10% of the data records, as soon as the poisoning percentage was further increased, the dynamic clipping performed better than all approaches. The higher granularity achieved when monitoring each node separately is able to better mitigate the poisoning attack. We concluded that dynamic clipping is the best option out of the three. Parameter values for each one of the techniques significantly affect the achieved accuracy. And as next steps, we see automated selection of parameter values, testing on diverse non-IID datasets, and using hybrid techniques for more flexibility. You can find our paper if you scan the QR code at the left side of the slide. Thank you.